Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu. Today, let's talk about mole calculations. This is a very important topic and will be used in many other chapters in General Chemistry 1, so please pay attention. Imagine you have a glass of pure water with a mass of 100 grams. If we want to count how many water molecules are there in this 100 grams of water, we can count that to be 3.35 times 10 to the 24th numbers of water molecules. Each molecule is very, very small. As you can see, this number very big, and it's not convenient if we want to refer to the quantity of water molecule. So we can convert that into use a more proper unit to refer to the quantity. Instead of saying this big number, we can say this amount of water is 5.56 mole of water. So yes, mole is a unit. The symbol is MOL. It's an SI unit of for amount of substance. And one mole by definition equals to 6.022 times 10 to the 23rd entities. Typically, we keep 4 significant figures in this number. And what we call this number is Avogadro's number. So this is a scientist who discovered this number for the first time. So we name it after the scientist's name. And Avogadro's number is a constant for any type of molecule, any type of particles. If you have 1 mole of that substance, there is 6.022 times 10 to the 23rd of this particles in that 1 mole. So it's a constant. The way to remember Avogadro's number is, it sounds very similar to Avogadro, right? At least that's how I remember this name. From this Avogadro's number, we can get the equation, the number of moles equal to the number of entity divides the Avogadro's number. Or in other ways, you can treat this equation as a unit conversion factor and convert entity and mole through a unit conversion, the box method. Let's take a look at a question. How many methane molecules are there in 5.72 moles of methane? Of course, we can use this equation. We already know the moles, and Avogadro's number is a constant, so we can transform this equation. Then the number of entities equals to the mole times the Avogadro's number, as is shown here. Then plug in numbers. The final answer is 3.44 times 10 to the 24th. Also, you can use a box method to do the unit conversion. We have 5.72 moles to start with. And then we put unit conversion factor here, 1 mole in the bottom to cancel out the unit, and 6.022 in the top, times 23rd in the top. We get the same answer. So feel free to choose whatever way that is, you feel most comfortable with. As long as you get the final answer correct, that's good. When we talk about moles, which is quantity, we usually will also talk about mass. So now we know 100 grams, within 100 grams of pure water, there are 5.56 mole of water molecules there. So what is the mass of 1 mole of water? Well, we can use this 100 grams divides 5.56 mole. Then you can get the number 18 grams per mole. So for each mole of water, you have 18 grams. That leads to another very important concept, the molar mass with uppercase M. So that refers to the mass of a mole of its entity. It may have many units. Of course, the derived SI unit should be kilograms per mole, right? But the common unit is gram per mole, and I'm going to explain why in a second. Let's take a look at this question. What is the total atomic mass of a water molecule? I'll give the two symbols from periodic table. And if we know for water molecule it's made of 2 hydrogen and 1 oxygen atom, we can add this atomic mass showing up in the periodic table, add them together as we have 2 hydrogens and 1 oxygen. So the total mass is 18.015 U. U is a unit of atomic mass. And round this number to a whole number, you get 18. Did you notice that the value 18 equals to the value of molar mass of water? So actually, the molar mass in the unit of gram per mole, pay attention to the unit, the gram per mole, equals to the molecular mass in the unit of U. So in other words, if you know the formula of a molecule, you can find the molar mass from the periodic table just by adding all these numbers up, all the compositions of atoms, and add them up. That's very convenient because we can use that in many calculations, and molar mass is actually one of the unique features of the molecule. Different molecules have different molar mass. And we can use that to in many calculations. Let's take a few practices. What is the molar mass of lithium, methanol, and calcium hydride? So for lithium, it's atomic element. So molar mass equals to the atomic mass, which you can find in the periodic table. We can round that to 7 gram per mole. Most of the time, you can round off atomic mass to whole numbers. I say most because there are few elements with a molar mass close to, say for chlorine, it's 35.45. It's kind of in between of 1. So it's very close to 5 in the first digits after decimal. So for those, we keep that as something 0.5. We don't round it off to whole numbers to just maintain the accuracy of the number. Okay, for methanol, we can add all them up. Remember, there are 3 hydrogens in CH3 and 1 hydrogen in OH. So altogether, there are 4 hydrogens. We can write the formula as it is, count how many atoms are there, and add all this atomic mass of atoms up. So for carbon, we can keep it as 12, hydrogen as 1, oxygen round it off to 16. So in total, the molar mass of methanol is 32 gram per mole. The same thing goes for calcium hydroxide. Add everything up. Whatever molecule atoms in the parentheses, the R get multiplied by the subscript outside the parentheses. So in this case, we have 2 oxygens and 2 hydrogens. The molar mass is 74 gram per mole. So make sure you know how to get the molar mass from formula and make sure you can get it correct. We're going to use the molar mass so many times in later calculations. All right. Now, I'm going to introduce one of the most important equations in this chapter. Mass of a substance equals to the molar mass times the number of moles. Pay attention to the unit. The molar mass is in the unit of gram per mole, and then the corresponding unit of mass is in gram. Say if you have a molar mass in kilograms per mole, then corresponding unit of mass will be in kilograms. So pay attention to the unit. They need to be consistent with each other. Usually, we combine this equation to the previous 2 other equations we have. One is a unit conversion factor. The other is how to get the molar mass from the periodic table. So now let's take a look at question. Graphite is a crystalline form of carbon used in lead pencils. How many moles of carbon are in 315 milligrams of graphite? So here's a picture showing what graphite looks like. Basically, it's an atomic element made by carbon. Okay, it asks for how many moles of carbon and it gives you the mass. Immediately, we should say, okay, we're going to use this equation from the top one. Number of moles equals the mass divides molar mass as shown here. So in order to know the moles, we need to know the mass of the graphite, which is provided here. However, it's in the unit of milligram, we want to convert that into the gram. And also for the molar mass, we can get it, the formula of graphite as carbon. So we need to find that in the periodic table. The molar mass for carbon is 12 grams per mole. Now we can get units ready for the mass. Use the box method, convert milligram to gram, and then we can get the mass is 0.315 milligram. Then plug these two numbers into this equation. Then we can calculate the moles of graphite is 0.0262 or 262 mole. All right, so this is the direct application of this equation. Let's take another example. Manganese is a transition element essential for the growth of bones. What is the mass in grams of 3.22 times 10 to the 20 manganese atoms? The number found in 1 kilograms of bone. So for this question, it asks you the manganese and in the mass of grams, right? So there are some other unnecessary information. For example, 1 kilograms of bone, we don't need to use that in the calculation. It gives you the mass and give you the quantity of manganese atoms. So actually we need to combine these two. Let's take a look at what manganese looks like. It's elemental substance. It looks like this. It's a transition metal. And now if we want to use the equation to get the mass in terms of the quantities, so mass equals to the molar mass times number of moles. The reason I picked this equation is it asks for the mass and provides the quantities. Although the quantity is not in the moles, but we can do the conversion of that to get number of moles. Okay, from this equation, the molar mass of manganese can be found in the periodic table. Then the molar mass is, we can run it off to 55 grams per mole. And the number of moles can be converted from the number of quantities here, right? Using the Avogadro's number. Okay. Now we know how to solve this equation, solve this problem. Let's get the number of moles first. Use a box method, right? So the number of moles of these amount of manganese is 5.347 times 10 to the minus 4 mole. Okay, and then we can get the corresponding mass of these amount of manganese. Plug in the numbers, 55 grams per mole times these amount of moles, and then the final answer is 0.0294 grams. Keep the same number of significant figures as what is provided in the question. All right, hopefully from these two questions, you can get an idea about how to do mole calculations by directly apply this equation or convert the quantity of particle entities into the number of moles. All right, this is the end of this video and see you next time.